Hello. In this video I'm going to give you some information on the Qlink project and explain to you what it is we're really looking to build. And that's the world's first decentralized mobile network. Now through that we want to extend network coverage to black spots and uncovered areas. And we want to improve upon the operation efficiency of traditional mobile network infrastructure. Now there are a lot of aspects of the centralized mobile network model that we really feel that we can improve upon by decentralizing and integrating blockchain. So some of those issues are difficulty in accurate content distribution and billing. So basically what that means is it's very hard for traditional network operators to see that user A has accessed content X and then bill based on that action accordingly. And that's important for reasons we'll get into in a little while. There are expensive usage-based fees, and operators are often caught overcharging customers. So I'm sure you or someone you know at one point or another has opened up a phone bill and found that it was a lot dearer than you're expecting to see. And there are also security issues surrounding certain types of data transmission. However, with the decentralized model and by integrating blockchain, we can accurately identify content and bill data consumption accordingly. So what this means is that user A can access content X, and then based on that, we can bill user A, or maybe we bill user B. So this opens up a whole bunch of new use cases that we'll get into. Users can pay for just what they want to use, and they can also be rewarded for watching certain content if it's sponsored content. So you can watch a video and then be rewarded in QLC tokens for your attention. Telecom assets can be registered and shared on the blockchain. So you can register something like your Wi-Fi or some SMS, and then you can share that with your friends or with your customers. And we also have the ability to encrypt sensitive information such as passwords, which contributes to the network security as a whole. So the basic concept of the Qlink network is that users can register and distribute telecom assets on Qlink. And they do this by registering them to the public chain as a digital asset. So the public chain is the Neo blockchain. You register your telecom asset, which could be a Wi-Fi, it could be content and data, it could be an SMS package, it could be a router, and that will become a digital asset with a digital ID, and then you can share that with your friends or with your customers, and you can share that for free, so at no charge, or you can choose to set up a smart contract and bill for access to that telecom asset. So this is how the users actually become the service providers of the network. So this is the first step in this decentralized model. So that all happens on the public chain. We also have the Qlink chain. Now the Qlink chain is there to deploy smart contracts and also record all the transactions on a data consumption and billing ledger. And these two chains will talk to each other via a cross-chain protocol. And this image basically illustrates this vision. So we have all the members of the network, we have all the connected devices, and everyone is contributing to the network in different ways. Now something I want to point out, we have these little pink things here. These are called Qlink base stations, and these are very cool. So the Qlink base station is basically hardware that allows every user to contribute network coverage. So that's 4G coverage and Wi-Fi coverage. They're no bigger than, say, a Wi-Fi router, and you can set it up in your home, in your workplace, and contribute to the coverage of the network. So, and the other thing that it does is when you're not using it for a data connection or a 4G connection, it has mining hardware that can kick in. So the device can mine the Qlink chain and validate and process transactions. So that helps to secure the network, and the users will be rewarded in QLC for doing that. So this is the second part of the decentralized model. We have the users who are the service providers, but we also have the users providing decentralized infrastructure as well through these base stations. Qlink have also signed a partnership with Centro Auto, who are manufacturers of electric vehicles. Centro Auto will be installing the Qlink base stations in all their vehicles to contribute to the IoT and their Internet of Vehicles, their IOV model, and it will allow all the vehicles to be able to send and receive data. So that's something we're very excited about. Now this diagram is the basic Qlink network structure, and it kind of goes back to what I was talking about a few slides ago. So here we have all the users who are registering their services to the network. So we have different kinds of services. We've got, so advertisers can register content, or regular users can register content as well. You can register Wi-Fi, data, SMS. Then we also have the Qlink gateway, which allows existing mobile operators to register data to the network, and so they can sell their existing services into the Qlink network. And the Qlink gateway will have a QLC to fiat clearance, so that will allow traditional network operators to participate in the Qlink network without having to worry about accepting cryptocurrency. But all these telecom assets are registered to the public chain, as you can see here. Now the public chain and the Qlink chain will talk via a cross-chain protocol, and the Qlink chain will deploy all the smart contracts, and it will record all the billing information and all the transaction information as well. This chain is being developed in collaboration with on-chain as well as the cross-chain protocol. Then we can see the Qlink chain allows access to the Wi-Fi, mobile data, and so on and so forth. And between the user and the Qlink chain is the Qlink application. So this will allow you to do things like find the Wi-Fi hotspots, to be able to access content, and so on and so forth. And then we can see that the QLC will flow between the different users of the network depending on what it is they're doing. So we have advertisers paying QLC to distribute content. We have users who are requesting access to certain features, paying QLC. We can also even have QLC flow all the way from the advertisers through to the users for rewards for participating and watching content. So this is our research and development team, and all three members, Alan, Chris and Owen, have extensive experience in the mobile telecommunications industry and also the blockchain industry. And they've done awesome things like build virtual SIMs from the ground up. Alan was a Huawei software engineer for a long time. So these men really have the experience and the capability to take Qlink's vision and make it a reality. So these are some of the applications that we're going to be building on the Qlink network. We have a Wi-Fi sharing platform that will allow users to register their Wi-Fi to the public chain and then share that with others. We have a content distribution platform that will allow content creators to register content to the network and then bundle it with data so that other users can access that content at no cost of data to themselves. And we also have an E2P SMS service that will allow users to register register SMS to the network and then sell them to others who need to use them. So we'll start with the Wi-Fi sharing. Wi-Fi sharing is actually a very large industry. The largest Wi-Fi sharing company in China has a $5 billion valuation. They have 300 million monthly active users, and they generate $1 billion in content business every year. So there are a lot of aspects of the centralized Wi-Fi sharing model that we really feel we can improve upon. The first one is security. Now, if you finish watching this video and you go to Google and you punch in, "How can I steal a Wi-Fi password?" you're going to find plenty of information telling you how to do just that. Basically, the way Wi-Fi passwords are transmitted at the moment is through something called a four-way handshake. And with the right know-how, it's relatively straightforward to be able to capture the password during that process and then you can crack it and the connection has been compromised. Using blockchain, Qlink has a method of authorizing the password to be transmitted P2P direct from the device to from the Wi-Fi device to the user's device. And I'll show you how that works on the next slide, but we feel like this really improves upon security. The second is there isn't really a lot of incentive to share your Wi-Fi at the moment. So unless you're something like an airport lounge or a coffee shop, you're really only doing it as an added convenience to your customers. And on the larger scale deployments, it's often very expensive to do as well. So businesses will look to offset those costs with something like advertising, which leads to advertisements being pushed upon the user as they browse the connection, and it's just a poor user experience all around. So Qlink, on the other hand, it's free to use after you've registered your Wi-Fi to the public chain. There's no further ongoing costs. You can receive rewards for sharing your Wi-Fi, so you can either choose to offer your Wi-Fi for free and just accept donations in QLC, or you can set up a straight billing contract. So you might say that every minute a user is connected to this Wi-Fi connection, they are charged 2 QLC. Or you can participate in content distribution. So you can allow certain users to access certain content, so it could be a video, and when users watch that video, they will receive a reward in QLC. They will get access to your Wi-Fi connection, but you will also get a kickback in QLC from the user who sponsored that particular content. So everyone kind of wins in that scenario there. The user wins twice. They get QLC, they get access to your Wi-Fi, you get QLC as payment for offering the Wi-Fi, and the content provider has that distribution channel. So this is basically the Wi-Fi sharing process. So we have the Wi-Fi sharer who will register their Wi-Fi to the public chain. So this is the Neo blockchain. Now when they do this, they will need to include information such as their MAC address, their SSID, their geolocation, and that will create a digital identity for that Wi-Fi connection. And if any of that information changes for any reason, the connection will need to be re-registered to the chain and issued a new digital identity. So then we have users who want to connect to the Wi-Fi. They open up their Qlink app and they will select the Wi-Fi that they want to connect to and accept the terms of the smart contract. So that might be free Wi-Fi, it might be charged per minute, whatever that might be. And then upon acceptance, that will trigger the public chain to broadcast the Wi-Fi info to the user and authorize the transmission of that password from the Wi-Fi directly to the user's device. And then the QLC is paid directly to the Wi-Fi sharer. So that's basically how that process works. Use cases for this: any hotspot owner who either wants to secure or monetize their hotspot. So if you go to the mall and you open up your phone and look at the nearby Wi-Fi hotspots, there's going to be tons. There's heaps and heaps of them available. So all of those businesses are potential users of this technology. Also, anyone who shares a close space, so it could be neighbors, it could be a shared workspace, those users can share the billing of their Wi-Fi connections by using Qlink to set up a smart contract that allows them to contribute QLC based on the length of time that they are connected. So that's just a way of distributing the costs proportionately to how much each user has used that connection. So we think it's got a valuable use case there too. So the next application is the content distribution and mobile data. So Qlink is able to track and record registered content accessed by each user and generate a ledger of data consumption. So what does all this mean and how does this work? Alright, so basically we have a content owner or a content creator. Actually, you don't even need to own the content. You can just be a user and register a piece of content to the network. You don't have to upload this content. All you do is register it. You provide the address, the location of where this content is hosted. So you do that through the Qlink app. And when you register the content to the public chain, it's hashed and a unique fingerprint is created for that piece of content. Now, on the other side, when users are browsing the Qlink network, whenever they access a piece of content, it's hashed again, and it also generates a fingerprint. Now, a file will only ever be able to generate the one fingerprint. However, if you change, let's say it was a video, and you changed it by half a second, the fingerprint would be different. But as long as the file remains the same, the fingerprint will always be the same. So what happens is if we find that a fingerprint generated upon accessing content is the same as a fingerprint that was generated upon registration of content, we realize we have a match, and we can add that to the content consumption ledger. And there are a lot of different things that we can do once we can identify that. So specific use cases. So we've identified that this data transaction has happened. We don't have to bill that data to the user. We can bill that data transaction to anyone. So that allows, in a sense, content providers to almost become data providers too. So I'll give you an example. How do we access Netflix at the moment? We go and we purchase our Netflix subscription for $10 a month or $12 a month, whatever that might be. But that's useless to us unless we have a data connection, right? You need to go and buy the data separately or your subscription is worth nothing. So using the Qlink network, someone like Netflix would be able to go and register all their content to the Qlink network, and then they would be able to purchase data on the network and assign it to their content. So then when a user wants to access a particular video, the billing of that data is billed to Netflix instead of the user. So Netflix could work that into their packages, and then users will be able to watch Netflix content without having to worry about using up all of their own data. This has other applications as well. Advertisers, because we can see who has accessed a piece of data, a piece of registered content, I should say, then we can not only bill different accounts accordingly, but we can also reward accounts accordingly. So I mentioned this earlier in this presentation, but an advertiser, let's say I'm a movie studio and I've got this new blockbuster movie coming out, and I've just released a new trailer. I want to make sure as many people see that as possible. I could register that trailer to the Qlink network. I could apply, say, 500 gigabytes of data. Then I could set a bounty of 10,000 QLC. And then depending on how big my video is and how many times it can be watched for 500 gigabytes of data, that QLC will be distributed proportionately to users who've come and watched my video. So that's a way of incentivizing users to come and take part and participate and give attention to your content. Other potential applications, online learning is growing all the time, and it provides a level of access to a level of education that some people would not have had otherwise. But in some regions, access to data might still prevent people from taking advantage of those opportunities. So education platforms could register all their content to the Qlink network, stuff like lecture videos and PDFs and whatever the students might need to complete their studies. So students will be able to access all that content without having to worry about the cost of data. So we really feel there's a lot of cool things that can be done with this. And this really benefits all the participants of the ecosystem. You've got content providers who have this whole new channel to promote and distribute content. You have content users who can view content for no data cost or be rewarded for participating and watching content, accessing content. And you also have the mobile data provider who is able to sell data to content providers, which is something they haven't been able to do before. And that's a whole new revenue stream. So we really feel this benefits everybody. So the final application is an E2P SMS service. Basically what this will do is allow users to register unused SMS to the public chain and package them up and sell them to enterprise customers who might need to use those SMS to distribute marketing messages to their customers. So the Qlink roadmap. There's a lot here, so I won't go over this in too much detail. We'll just kind of go over the highlights. So Qlink have already developed a BOS system, developed virtual SIMs. We've completed a test on Ethereum. We actually built a lot of this on Ethereum previously to deciding to build the Qlink chain and switch to the Neo blockchain. The reason we did that was because it was just too expensive to run on Ethereum, but a lot of this has already been built once. We've completed the proof of concept, the white paper, transferred the virtual SIM platform to Ethereum, and completed the SMS billing smart contract on Ethereum as well. In Q4 of this year, we're completing the SMS and Wi-Fi MVP, launching the P2P protocol, and launching the smart contract for SMS and Wi-Fi sharing as well. Next year, we'll launch the SMS and Wi-Fi product, as well as the SDK and P2P protocol. We will integrate with the IPFS and launch the Wi-Fi smart billing contract. So that's all going to happen in Q1. Q2, we will publish the SMS and Wi-Fi SDK. We'll publish the mobile data and content distribution MVP. We'll launch the mobile data billing and launch the mobile data billing smart contract. In Q3, we'll publish the Telecom public chain trial network and cross-chain protocol. We'll publish the Qlink wallet trial version, publish the Qlink gateway, publish the Qlink chain smart contract API, and in Q4, we will publish the Telecom public chain, which is the Qlink chain, publish the Qlink wallet, update the development guidelines, and then launch the Qlink base station. So these are some of our advisors. We have a lot of experience on our advisory board. As you can see here, we have one of the co-founders of Alibaba. And we also have the former CTO of StarHub, who are the second largest telco in Singapore. So we've got a lot of great experience and guidance here. And this is our business development and marketing team. So Susan is the co-founder of Qlink along with Alan. Toya is the head of marketing and PR, and she has experience as the former senior PR manager of OKCoin. And we also have Roger and Tony, who have a wealth of experience in IT and managing tech startups. If you want to connect with Qlink, you can do so via the Telegram. We encourage you to come and join the conversation on t.me/Qlink Mobile. We also have the website at qlink.mobi and the Twitter at twitter.com/QlinkMobi. So thanks for watching the presentation, and we hope that you guys can come and join us and become a part of the world's first decentralized mobile network.